Chapter 13, Number 37. A freshly caught catfish is placed on a spring scale and oscillates up and down with a period of 0.204 seconds. If the spring constant of the scale is 2160 newtons per meter, what is the mass of the catfish? So our really quick picture is something like this with, I don't know what a catfish looks like, but I can't really draw fish anyway, so something like that. And we were saying that the catfish does an oscillation with a period that is 0.204 seconds. And we know that the period for a spring system is 2 pi times the square root of the mass over the spring constant. So we can just solve this over. We can square both sides, and we get t squared equals 4 pi squared m over k. That 4 pi squared happens a lot. Please remember, it's 2 pi all squared. So you get 4 pi squared. And then we can just solve over and say that the mass, cross multiplying by k and dividing by 4 pi squared, we get kt squared over 4 pi squared, or 2160 newtons per meter times 0.204 seconds squared over 4 times pi squared. We get 2.27695 kilograms, which of course, based on our sig figs, where we have 3 sig figs, means that we get 2.28 kilograms. This is one of the cases where there are just potentials for lots of weird algebraic errors. For instance, we're dividing by 4 pi squared. When you put that in your calculator, you probably should put that in parentheses, because you don't want to divide by 4 and then multiply the whole thing by pi squared, which is, if you typed it straight, what you would get.